back to Ashilebe Latifat Online Academy. So in today's class, we want to solve this beautiful trigonometry question. Now, given that tan theta is equal to y, expressed in terms of y, sine 2 theta, 2 cos 2 theta. Now, solution. If you look at this sine 2 theta, by addition formula, you know that we have sine a plus b is equal to sine a cos b, then plus cos a sine b, and so on. Now, you can see that this 2 theta, we can express it as theta plus theta. So sine 2 theta is the same thing as sine theta plus theta. So from here we can now say that sine theta plus theta will be equal to, anywhere I see A, anywhere I see B, I'm going to put theta there. So I have sine theta cos theta plus cos theta sine theta. Now I can rewrite it as sine theta cos theta plus sine theta cos theta. You can see that they are like terms. So this is my sine 2 theta. So from here, sine theta cos theta plus sine theta cos theta is equal to 2 sine theta cos theta. So that means sine 2 theta is equal to 2 sine theta cos theta. Having known that, we can now say that this 2 sine theta cos theta is the same thing as 2 sine theta cos theta over 1. You can see that I did not make any magic here. So from here, since I want to do this expression in terms of tan theta, which is y, so I have to manipulate this one to be in form to become sine square theta plus cos square theta is equal to 1. So anywhere I see 1, I'm going to put sine square theta plus cos square theta there. So that means, so it's only for this right hand side. So it's the same thing as 2 sine theta cos theta divided by sine squared theta plus cos squared theta. Sine 2 theta is equal to 2 sine theta cos theta divided by sine squared theta plus cos squared theta. So I can name this one equation 1. So now, the right hand side of equation 1, we are going to divide both the numerator and denominator by cos squared theta. So divide then both sides are both the numerator and denominator by cos squared theta gives me 2 sine theta cos theta over cos squared theta, then that is numerator. So for denominator, sine squared theta plus cos squared theta divided by cos squared theta. So I will have here cos theta cancel one of this cos squared theta. So the numerator, becomes 2 sine theta over cos theta. Now, the denominator, I have sine square theta over cos square theta, then plus sine cos squared theta over cos squared theta. Why do I do that? Because it's like if I find the LCM of cos squared theta and cos squared theta, I'll have cos squared theta. Now cos squared theta in cos squared theta is 1 multiplied by sin squared theta gives me sin squared theta plus how many cos squared theta can I get in cos squared theta? 1. 1 multiplied by cos squared theta gives me this. So you can see that they are still the same thing. So from here cos squared theta cancel cos squared theta. So the denominator, so we're still on denominator, is, so recall that sin squared theta over cos squared theta is equal to tan squared theta. So anywhere I see sin squared theta over cos squared theta, I'm going to put tan squared theta. So I have tan squared theta plus 1. That is the denominator. Now numerator, I have 2 tan theta. So sin theta, since sin theta over cos theta is equal to tan theta. Now, so the whole expression, the right hand side now becomes 2 tan theta over 1 plus tan squared theta. Or if you like, you write tan squared theta plus 1, still the same thing. Now, sin 2 theta is equal to 2 tan theta divided by 1 plus tan squared theta. Or you can say that sin 2 theta is equal to 2 tan theta divided by tan squared theta plus 1. It's still the same thing. But you have to recall that we were given that tan theta is equal to y. So anywhere we see tan theta, we're going to put y there. Now, sin 2 theta will now be equal to 2y over 1 plus y squared. So that is number 1. Number 2, cos 2 theta is the same thing as cos theta plus theta. Now, according to addition formula, cos A plus B is equal to cos A cos B, then minus sin A sin B. So here our A is the same thing as B, which is the same thing as theta. So anywhere I see A, anywhere I see B, I'm going to put theta there. Now I can now say that cos theta plus theta is equal to cos theta minus sin theta sin theta. So cos 2 theta is equal to cos theta is the same thing as cos squared theta, then minus sin squared theta. So if you substitute the value of cos squared theta to be equal to 1 minus sin squared theta, then you have your cos 2 theta still the same thing as 1 minus 2 sin squared theta. So if I want my cos 2 theta to be in form of in terms of cos, so then I have 2 cos squared theta minus 1. It depends on which one I want to work with. Since I'm working with tan theta, so I can easily use cos squared theta minus sin squared theta. So I have my cos 2 theta to be equal to cos squared theta minus sine squared theta. So over 1. I have to recall that my 1 is the same thing as sine squared theta plus cos squared theta. So I have cos 2 theta to be equal to cos squared theta minus sine squared theta over sine squared theta plus cos squared theta. So I'm working with tan. So I need to divide both the numerator and denominator by cos squared theta. So I have cos 2 theta is equal to cos 2 theta minus sine squared theta, cos squared theta rather, sine squared theta minus sine squared theta. Everything over cos squared theta. Then the denominator sine squared theta plus cos squared theta over cos squared theta. So let's separate it. Numerator, I have cos squared theta over cos squared theta minus sine squared theta over cos squared theta, like I explained in the first one, the number 1. So this cos squared theta cancel cos squared theta, so the numerator becomes 1 minus tan squared theta, since sine squared theta over cos squared theta is the same thing as tan squared theta. The denominator is now sine squared theta over cos squared theta, then plus cos squared theta over cos squared theta. Here is the denominator, here is the numerator. So cos squared theta cancel cos squared theta. So the denominator becomes tan squared theta over cos squared theta gives me tan squared theta. So I have tan squared theta then plus 1. So now back to cos 2 theta. The numerator is 1 minus tan squared theta, and the denominator is tan squared theta plus 1, which is still the same thing as 1 minus tan squared theta over 1 plus tan squared theta. Because this tan squared theta plus 1 is commutative, so we can rewrite it still the same thing. So, and we have to recall that tan theta is equal to y. So anywhere I see tan theta, I'm going to put y there. So cos 2 theta is equal to 1 minus y squared over 1 plus y squared. So that is how to do it. So if you have any problem with it, please let me know in the comment section. Thank you. God bless you. Bye bye.